We are given an orthonormal coordinate system. That means the axes are perpendicular and the unit vectors have length 1. The system is labeled O, U vector, V vector. There are 2 points, A and B. Their complex coordinates are, A equals 2 times e to the power of I pi over 6, B equals 2 times e to the power of I pi over 4. Question 1, Part A, plot the points A and B. The number A is written in exponential form. Its modulus, that is, its distance from the origin, is 2. Its argument, the angle with the positive real axis, is pi over 6 radians, which is 30 degrees. So, point A is located 2 units from the origin at an angle of 30 degrees from the positive x-axis. Similarly, point B has modulus 2 and argument pi over 4 radians, which is 45 degrees. Point B is 2 units from the origin at 45 degrees. To plot them, draw a circle centered at O with radius 2, use a protractor to find 30 degrees and place point A, then 45 degrees for point B. Question 1, Part B. Write A and B in algebraic form. Use Euler's formula, e to the power of I theta equals cosine theta plus I times sine theta. Start with A equals 2 times e to the I pi over 6. So A equals 2 times, open parenthesis, cosine of pi over 6 plus I times sine of pi over 6, close parenthesis. Cosine of pi over 6 is square root of 3 divided by 2, sine of pi over 6 is 1 divided by 2. Multiply by 2, A equals square root of 3 plus I. For B, B equals 2 times e to the I pi over 4, which gives 2 times, open parenthesis, cosine of pi over 4 plus I times sine of pi over 4, close parenthesis. Cosine pi over 4 and sine pi over 4 are both square root of 2 divided by 2. Multiply by 2, B equals square root of 2 plus I times square root of 2. Question 2, Part A, find the complex coordinate C of point C. Real part of A is square root of 3, imaginary part of B is square root of 2. Point C is at x equals square root of 3, y equals square root of 2. Complex coordinate C equals square root of 3 plus I times square root of 2. Question 2, Part B, verify C squared. C is square root of 3 plus I square root of 2. C squared equals open parenthesis, square root of 3 plus I square root of 2, close parenthesis squared. Expand x squared plus 2xy plus y squared. First term, square root of 3 squared is 3. Second term, 2 times square root of 3 times I square root of 2 equals 2I times square root of 6. Third term, I squared times, square root of 2 squared, equals minus 2. Add all, 3 plus 2I square root of 6 minus 2 equals 1 plus 2I square root of 6. Question 3, Part A, show that OD equals 5. Point D has coordinate D equals C squared, which is 1 plus 2I square root of 6. Distance OD is modulus of D, square root of, 1 squared plus, 2 square root of 6, squared, equals square root of 25 is equal to 5. Question 3, Part B, geometric construction of D. Coordinates x equals 1, y equals 2 times square root of 6, approximately 4.9. Construction, start at the origin, move 1 unit to the right, then 4.9 units up, and mark point D. Question 4, solve 2z squared minus 2z minus I times square root of 6 equals 0. Quadratic formula, z equals open parenthesis, minus b, plus or minus, square root of delta, close parenthesis, divided by 2a. Here, delta equals 4 plus 8I times square root of 6, which equals 4c squared. Square root of delta equals 2c. So, z equals open parenthesis 2 plus or minus 2c, close parenthesis, divided by 4, equals open parenthesis 1 plus or minus c, close parenthesis, divided by 2. Solutions, z1 equals open parenthesis 1 plus c, close parenthesis, divided by 2. z2 equals open parenthesis 1 minus c, close parenthesis, divided by 2. Question 5, Part A, midpoint M1. Point I has coordinates 1 and 0. Midpoint of IC equals open parenthesis 1 plus C, close parenthesis, divided by 2, which equals C1. Question 5, Part B, parallelogram OCM1M2. Vector OC equals C. Vector M2M1 equals Z1 minus Z2, which equals C. Therefore, the quadrilateral is a parallelogram. Question 5, Part C, approximate coordinates. Square root of 3 is approximately 1.732. Square root of 2 is approximately 1.414. M1 is approximately 1.37, and 0.71. M2 is approximately minus 0.37, and minus 0.71.